Hello, Engineer Chima.
Hello, yeah, Engineer Uche, I'm here. I can hear you.
Okay, good afternoon. So I'm going to make you the host. So be on the lookout to add other people. Okay.
Okay.
On the room, yeah. So as usual, maybe in 10 minutes you start.
Yeah, exactly. No problem.
Thank you. Yeah.
Okay, so Chima, we start in 10 minutes, correct?
Yes, we'll start in 10 minutes.
Okay, so I'll join you later then. Okay.
All right.
The 10 minutes is for grace for others to join, please. Thank you.
So we start, just to be clear, I think we'll be starting by 3:10, right?
The idea is for others to join.
Yeah, no, I just want us to be clear because it's 3:04 now. When you say in 10 minutes, I say 3:14 or 3:10. Okay.
6 more minutes.
Okay. Okay, I'm so sorry. I paused the recording while we are waiting for 10 minutes and then I forgot to turn it on again, but it's now started. Okay, so like I was saying.
But sorry, sir.
Okay.
Hello, sir.
Yes,
the recording is very important. I may advise if you just briefly say something about what you've discussed before, not as much as you have taken it step by step, but brief, you just briefly go through since you just started recording. I think it will help.
Okay, no problem. Let me just go back and I won't go into much detail. Just yeah, it's okay. So I think I'll start here when I talked about, okay, let me talk about the concept of sustainable energy development. So I said that the sustainable energy development has basically two major components, the energy efficiency component and then the renewable energy component. And then the energy efficiency component is believed that if you implement energy saving measures, you should be able to save your, reduce the amount of energy that you consume, in many cases as much as 30% or even 40%, okay? So if you're able to reduce the energy consumption in your facility for like 30%, then it is expected that the remaining consumption should now be switched into renewable energy source, which is where we'll now get the whole concept of the sustainable energy development. You reduce your energy consumption, then you now generate your required energy through a renewable energy source. Once you combine these two successfully, then you can say to have achieved 100% sustainable energy system. So then we went ahead to start with energy purchasing and accounting, where we'll have to talk about the components, things that makes up your energy bill. As an energy consultant, you need to understand how your energy bill is being calculated so that you know when an error has been committed in the billing system of your client, and then you can be able to advise appropriately. So these are the things that we are going to cover in this session. Okay, so we have to start with the energy rate and the tariff structure. Then I talked about that if you, I think I need to mute everyone. I'm hearing some noise. Or you can just please mute yourself. But if you need to speak, then you unmute yourself. So the energy bill is made up of a number of components that we should try to have a basic understanding of. which is what we're going to try to unpack in this session. Most energy providers are essentially resellers, where they buy energy and sell to their end customer with their own commitments to pay back their supplier. So they buy from the generator, they sell to you, they collect money, they pay back to the generator and the gas supplier, where the primary fuel comes from gas and all of that. So in most countries, the energy infrastructure is regulated, which in effect means that there are a number of separate elements of the bill to pay. So we will align some of those elements in this session. So first of all, you have a physical plant, which in most cases are the generation plants, okay? That's where electricity is being generated. And once they are being generated, their voltages are being increased. There is a step up in their voltage. In Nigeria, our maximum voltage is 330 kilovolts. What you consume in your house is 0.415 kilovolts. That's what you consume in your house. But you can imagine the difference between 330 kilovolts to 0.415. And the reason for this high voltage is so that it's able to travel a very long distance. Electricity system that we run in Nigeria is a centralized system. A lot of the power plants are concentrated in the south, maybe rivers. Some are in Kogi State and some are in, is it Lagos or Ogun State? I know one is around Ogun State and all of that. But you can imagine the distance where this electricity that you consume in your house is coming from. So they need to travel this long distance to get to you. And this is the reason why you need to increase the voltage to 330. And I explained that the voltage is like a pressure the pressure in your water pipe, okay? So if you increase the pressure, you have more water to flow. You can push that water through a longer distance. That's synonymous to what the voltage does in the electricity system. And that's how when the voltage is not being stepped up, it now passes through the transmission lines and it gets to the substation. The substation is where those high voltage are being stepped down, to a lower voltage, not necessarily the voltage that comes into your house, but a lower voltage that enables the distribution company to also push it up to the point it's nearer to your house. Then they have to step it down again to the level that it now gets into your own house. So all of these components or elements are cost. They have costs associated with them, which is also part of what you're paying as an energy consumer. So you need to understand all of these things that makes up your electricity tariff. So you now have the distribution company that eventually brings this electricity to your house. So this is what we are very familiar with, the DISCOs or the PACN or the NEPA that we call them. So if you're in Abuja, they are called Abuja Electricity Distribution Company. If you're in Port Harcourt, Cross River, South there, it's Port Harcourt Electricity Distribution Company. If you're in Lagos, there are two of them in Lagos. You have Eco Electricity Distribution Company, you have Ikeja Electricity Distribution Company, depending on the region where you live in Lagos. So most of us have meters in our house or in our offices. Now, meter is a device that used to measure the amount of energy that you consume so that you can be able to pay for what you consume. There has been a lot of agitations on meter where some of these discourse are billing people arbitrarily on estimated billing. So in that case, there is no way for them to know the amount of energy that you consume. So they just sit down in their office and assume that this is what you should have consumed, and they bill you based on that. And there's a lot of agitations on that, but it's not transparent. Okay, it creates room for exploitation of the masses. And there has been a lot of outcry on this. And the federal government has also stepped in with their mass metering program, okay, so that everybody gets metered. And they are doing this because of the fact that they are now increasing the electricity price. So if you're not increasing the electricity price, I think it's only fair that you give me the right bill for what I consume, which is the reason why the federal government have to come in and intervene by bringing in the fund to provide meter for everyone. Now, you will notice that all of this has their own cost components. The distribution company doesn't have enough money to provide meter. That's why the federal government is coming in the first place. And the federal government, I'm not so sure this is a free money. I think it's a loan, or I don't know if, or I'm not so clear if it's a loan or it's the money they're going to pay back. But somehow, you who is a final consumer, somehow you have to pay back this money through your energy consumption. Okay, so it's important that you understand how all of this ties back into the electricity rates that you pay in your houses. So you have administrative costs. These distribution companies, the transmission companies, the generation companies, they all have their staff that or that takes care of these processes. Okay, so they need to be paid. Now the generation companies, they have most of them have obligation to pay their fuel suppliers. Okay, which is where they derive the energy from. Now, mind you that the physical asset that we talk about in the first place, that is just an energy converter, so to say. It is an energy converter. So you have to feed in the energy source for it to convert to electricity. We need to understand this very clear. Okay. So now, in this case, you were talking about energy. We are not talking about the fuel cost component of your bill. Okay. So that's why you have the energy here. So like I said, in Nigeria, about 70% of the electricity that we consume from the national grid comes from gas. Then about 30% comes from hydro. So we now have interest on debt. Sometimes these utility companies, sometimes they borrow money and they have to pay back with an interest. All of this has to be somehow tied back into your bills. And they have to make profits for themselves and for their shareholders. You are paying for all of this in your bills. So now this is a snapshot of the entire process. So first of all, you have the generation company. I think there has to be another one here that supplies the fuel to these generation companies for them to generate the electricity. So this electricity is now stepped up. This is a step-up transformer to high voltage. So it can go through a long transmission process. Then when it gets to the region where it's needed, it has to be stepped down. Okay, this is a step-down transformer up to the point where it gets to the voltage that can be delivered into your home. Okay, so and I went from here and I went ahead to say that companies like Dangote Cement, which is a big company, okay, the amount of energy that they consume is so large that your distribution company might not be able to supply them from their system, from their facility. So what most of these big companies, what they do is that they have their own power plant. That's why you find out that a lot of heavy industries are in Lagos, because there's a gas pipeline that runs through Lagos. So it is easier for them to tap into that gas pipeline, build their own turbine generator, and generate their own power, because they consume a lot of power, right? So for such company, they cannot take their power from distribution company. You can imagine that one company can consume what entire distribution company can supply to one district. So for example, if you're in Port Harcourt, the whole energy consumption of a Port Harcourt city, assuming there are no heavy industries in Port Harcourt, is equivalent to what one industry can take for their operation. Okay, so the distribution company facility cannot be able to supply them those kind of energy. So in this case, if Dangote, for example, wants to buy power directly from the generation company, so they don't want to go through the distribution company because their facility is not robust enough to sell this energy to them. So they want to buy straight from this transmission. So they go and negotiate with generator on a price, how much they're going to sell electricity to them. After negotiating, they'll have to come to the transmission company and negotiate how much this transmission company is going to take to transmit this power from the generator to their own company, which is Dangote. I'm using Dangote as an example. It could be any other company. Okay, so this charge that this transmission company is going to collect to transport this electricity from here to their company is what we call transmission use of system charge. Okay, the distribution company pays it as well, but it is not embedded in your tariff as a final consumer. But I use Dangote as an example so that we can understand clearly what this transmission use of system charge is all about. It's not something that is so familiar, but if you operate if you go into consultancy with large organizations like Dangote, Bua Cement, and the rest of them, you might begin to see such terms like transmission use of system. Okay, so it's important that you understand what it means. So this charge is the cost that the transmission company will collect to transport this energy from a large generator to the facility or the company. So that's what transmission use of system is. So we now have distribution use of system. Okay, now imagine that you don't want to buy electricity. Maybe you're Dangote, but you're not so big as Dangote. The distribution system can still sell to you, but you don't want to be buying from the distribution company. You come and talk to this generator that, look, I want people to step out this power through want to remain competitive.
Please.
Chima, we lost you. I don't know if
You
it's
want
just
you don't
me.
want the distribution company to add so much a better rates with the generator. Now the distribution facility to get to you.
Sorry, Chima, you've been breaking intermittently.
Exactly.
Can everyone hear me?
Yeah, I can.
Hello.
I can hear you now.
I don't know what happened. It seems there was an interruption.
It's still breaking. The network is really bad.
Yeah, there was an interruption. So yeah, but I think I'm back now. So let's continue. So I was trying to explain the distribution use of system. So assuming that you're a smaller Dangote and you want to go through the distribution companies to get your own supply, then you have to pay transmission use of system as well as distribution use of system. Okay, this is not very well applicable in Nigeria, even though there was a regulation that allows you to do that. So if you have an estate and you don't want to buy from, if you have an estate in Lagos, you don't want to buy from Eco, you can go and negotiate with one of the generation companies, maybe Geregu or Afam, or I mean, there's quite a number of generation companies in Nigeria. You can go and negotiate with them. Then you pay your transmission use of system, you pay your distribution use of system, then the energy will be delivered to you. It's not very common yet, but as the market evolves, as the market develops, we can get to that point where you begin to hear distribution use of system. But it is good and very important that you understand what it means. So now we talk about demand charge, okay? Now, investment in electricity is so huge. It's not a small investment. For the fact that you flip the switch and the light comes on, it has a lot of capital investment that enables that to happen, right? And they don't want you to use this electricity anyhow. They don't want you to use it anyhow, in the sense, in the further slide, I'm still going to explain the demand charge, but I'm just trying to give a little bit overview of what this demand charge is. It is a mechanism to discipline you as a consumer so that you can consume energy or electricity more responsible. That's what it is. So it's just a mechanism to discipline you or to control your consumption behavior, right? So that you don't consume it anyhow. So imagine that I pass my neighbor generator. It is true that you know that you cannot power your refrigerator or your AC with I pass my neighbor generator, right? You can only power your little appliances. So they want to make sure that you don't put so much load on their facility that is greater than they can sell to you, that is greater than the capacity of their facility. That's what this demand charge is all about. They want to make sure that you remain within the limits of what this entire facility can supply, right? So we'll explain that further with some diagram. So now let us but in this case, we are not looking at how some of these things that we've explained in the previous slide, how they appear on your bill. Okay, I talk about transmission, I talk about generation, I talk about meters. Now in your bill, you're not going to see meters. Okay, so I'm going to explain how they appear on your bills. So first of all, you have what we call the service charge. You most likely going to see this in your customer's bill. Okay, so what does service charge mean? Service charge means charges that are paid for fixed utility charge every month, which pay for the portion of the ongoing services, such as metering, maintenance shops. Okay. Now, these are more like a fixed, this cost has to be paid by the, that is, it's more like a fix. It's like a fixed charge that you pay every month. Okay. Someone is ready. Jibril, you're ready?
Yes, sir.
Jibril, you want to ask the question?
Yes, sir. I don't know whether am I the only one getting it like that,
ahead,
or
please.
someone also complained about it.
Yeah, you're not the only one. It's been breaking. So
So that's the confirmation. It's really, really breaking. It's not flowing at stuff. You know.
I'm finding it difficult to. Can somebody can you repeat what again, Jibril? I didn't get that.
Your network is not stable. That's why you're breaking.
What I said was that the network is, we're not getting you. It's really breaking, it's hanging, and we keep better, but no, it's
Can you hear me now?
now.
Hello,
With
can
that
you
question you
hear
asked.
me? Can you hear me now? Is it better now?
it's not
No,
better.
it's
It's
not
not better. And Jibril, when you speak, it also hangs. So I don't know where the problem comes from. So maybe, I don't know, maybe the host needs to change the network also.
At least I can hear participants.
Can you speak again? Let me understand where this is coming from, because Jibril also seems to be having some challenges from his own end. But I heard you loud and clear. I mean, Ekaite, but I'm unable to hear Jibril very well. So I want to know where this is coming from.
You're good now. As you're speaking now, you're good.
Okay.
Chima, do you hear me well?
I heard you. I thought that was okay. I heard what you said, but
No,
I was
this
unable to
Ephraim.
hear what Jibril.
Yeah.
Okay, Ephraim. Yeah, I was unable to hear Jibril, but I heard you, Ephraim. I heard you very well, but I'm unable to hear Jibril. So I need to also know, because I need to know where exactly this is coming from. Jibril, can you speak again? Let's see if we can get you clearly.
You mean the network issue or the complainant?
Okay, it's better now. We can hear. You know, at the first time when you started speaking, it wasn't clear. I mean, it was kind of blurred at some points, breaking, but it's clear now. So let's
what
proceed.
happened was that from both of you, the lines were breaking. Both you, Chima, and that of Jibril. So that's what happened.
Okay, but it's clear now, right?
Yeah, there's still a slaw on your own, so I don't know how long the network will sustain.
Okay, so if it continues, please let me know. So let me know if I'm to switch network.
Sorry, is that Engineer Ephraim or who's the other speaker?
Yeah, it was Ephraim.
If you can switch.
It was the last person that spoke was Engineer Ephraim. Okay. Please, can you hear me now? Can you hear me?
Yes.
Yes, we can hear you now.
Okay. So before the question by let me put down your hand. I think okay. So I was talking about the service charge, because like I was saying, all those components that I discussed about, the element that makes up your electricity bill, you're not going to see them as it is in your bill. So you're going to be seeing something like service charge. And here, I'm trying to explain what the service charge is. So the service charge is more like the recurring expenses for maintaining the power stations and making the electricity available to you whenever you need it. So you're talking about maybe maintenance, metering costs, maintenance, administrative charges, okay? So all of these are what makes up your service charge. And in most cases, it is fixed. If you remember very well, around 2013 or 2014 downwards, we had a fixed component on our electricity bill. So every month there's the amount of money that you pay, whether you use electricity or not. So that is the whole essence of service.
The issue is back.
But of course, we know here in Nigeria, because of agitation, which now leads to the review and embedded into your energy charge, okay? It's monthly charge that you pay for administrative. Is someone asking a question? Okay. Am I audible enough? Can everyone hear me? Hello?
I can hear you now, but the thing started going up and down before now.
Can you hear me? I need to confirm. Okay, maybe I've got.
Actually, it's when,
okay,
when
so
you say,
now,
can we hear you
is
now?
the cost charge per kilowatt hour? Okay. Is anyone asking a question? Otherwise, I continue. So I'm talking about energy charges. Now, it is the cost charge per kilowatt hour for electricity. Hello? You said that the network is still working?
Yes, it's still breaking.
Oh my goodness. Let me, because I know this is the best network I have here. If I switch to the alternate network, I don't know how. I think that one might be worse. But let me try. Okay, let me just continue. I'm using a different network now. Let me see. But if it continues, please let me know. I need to be sure that you heard me. Hello?
Chima.
Can anyone hear me?
Yeah, I can hear you. I can hear you.
Okay. So I said I just switched network, and I need to confirm that you can still hear me. That's the question I asked.
Yeah, I can hear you now, but they say a little slow. So I'm not sure if it will be sustained. I think you can go ahead. If there's a problem, I'll let you know.
Okay, please let it come to my attention if this continues. So I'm talking about the energy charge. So it is the cost per kilowatt hour for electricity consumption And this is based on total number of units consumed over a billing period, usually 30 days. This is a monthly billing. So on your energy bill, you're going to see the energy charge. Now, you're going to see the certain quantity of electricity that you consume per kilowatt hour. Okay, so it is this very amount, it is this very number of consumption that you will have to multiply by unit cost to get your energy bill. I mean, your energy charge. Okay, if there are other components, you also need to calculate them. We'll go into some of those calculations shortly, but I just needed to explain this concept and elements. So we have the power of fuel adjustment charge. Now, bear in mind that you're not going to see all of this in the Nigerian bill, but it's good, you know, so that when you're not dealing with an international client, when you start seeing some of this, you understand what it actually is. Okay, and for Nigerian markets, we are still growing. We are still at a very nascent stage. We are still growing. The industry is still metamorphosizing. So we'll get to the point where we'll have a full, there's a time we use it, because now we are in transitional electricity market. Transition, meaning that we are just transitioning from one stage to another. So we'll get to the point where we'll have a full operational market, right? At that point, you can easily decide to buy from maybe Port Harcourt distribution company, or you can decide to choose your supplier. That's what it is actually. I mean, at the final stage of it, you can decide to switch who supplies you electricity, and that's the situation in UK at the moment, where you can actually choose who sells electricity to you. So Nigeria is still on the way, you know, towards that process. So by the time we move into we advance into the electricity market, you might begin to see some of these charges. So we have the demand charge. I already explained what the demand charge is. So we have what we call a ratchet clause. Ratchet clause is similar to demand charge. Okay. Now, ratchet clause, because they don't want, like I said, the demand charge, the electricity providers, they want you to consume this electricity. They want to consume the energy responsibly. They don't want you to just, you know, switch on your devices anyhow. Okay, so that's why they now introduce this ratchet clause. Okay, it's either they use ratchet clause to modify your behavior or to discipline you, or they use demand charge. Both of them are used to achieve the same objective. Okay, but in some cases, in countries where ratchet clause is being used, the utility is at liberty to determine whether to use ratchet clause or to use demand charge. Okay, so when they do calculation for ratchet clause, they do calculation for demand charge, they now see the one that pays them more. If they're going to collect more money from you using ratchet clause, they will use ratchet clause. If they're going to collect more money from you using demand charge, they will use demand charge. Both of them are just tools to control your behavior. So we now have the power factor charge.
Excuse me, Chima.
Yes.
So what's the difference between them, demand charge and ratchet clause?
I'm going to explain that in the next. Okay, let me just do a brief explanation here. But even though there's a more detailed explanation, I should go ahead. Okay, so I will get to that. There's an explanation. But what's important now that you know that both of them are tools to control your consumption behavior. Just get that understanding. When we proceed, I will then explain further where we can even do some little bit examples, some calculations for both demand charge and ratchet clause. You understand it clearly at that point.
Okay.
Okay. So we have power factor charge. Okay. I'm also going to explain this. Now, the essence of this slide is just to show you different components that you can see on your bill. Okay, different charges that you can see on your bill. Okay. When we now begin to do calculation of this billing system, you understand it clearly how they are being calculated. So power factor charge, they also want you to make sure that you don't, you know, those of you that participated in our previous training, you won't have a problem understanding what a power factor is and the problem that it causes. Okay. So the distribution company, they want you to maintain a good power factor level. The power factor can be between 0 to 100%. Or between 0 to 1, either as a factor 0 to 1 or as a percentage 0 to 100. Okay, if you're using your electric boiler and you're taking power from the grid and you're using your electric boiler alone, then your power factor is 100% or is 1. But if you're using an electric motor, so for example, if you're using a blender, okay, even though now power factor is mostly applicable to industries where they use a lot of electric motors, okay. So if you introduce electric motor into the system, it affects the power factor a lot, right? And once it affects the power factor, the utility company would be losing money. So they don't want to lose money on their infrastructure. So they want you to make sure that you have a good power factor in your consumption. That's why they introduce this charge here. So if you have a poor power factor, they will charge you for having a poor power factor. I will explain, I mean, we will see example of this as in subsequent slides. Okay, so now let's talk a little bit about demand charge. Like I said, we explain all of them in further detail. Now, demand charges are based on your rate of energy consumption rather than energy. Okay, so it's a measure of how fast you consume electricity. Okay, the electricity that flows into your facility. So if you consume the electricity faster, the bigger the wires and transformers and the generators will become. Now, let me illustrate this further. If you're running an air conditioning system in your house, if you're running maybe 1 kilowatt unit of air conditioning system, okay, in your house, if you run it 1 hour, okay, now the capacity of the air conditioning system is 1 kilowatt. Can you see my cursor where it's pointing at?
Yes.
Okay, so your air conditioning system is 1 kilowatt. That is the capacity of the air conditioning system. If you run it for 1 hour, mind you that energy is power times time, right? So if you times this 1 hour by 1, you have 1 kilowatt hour. Are we clear?
Yes.
Yes.
Okay,
Yes.
okay. So in this case, your energy is you've consumed 1 unit of energy for running that air conditioning for 1 hour. But look at your demand. You just consume 1 unit in 1 hour. Okay, meaning that you cannot provide a generator of 500 kVA to service this load. You cannot. You must provide a higher capacity generator, right? So if we understand that, let us look at this next diagram here. Now imagine that you're running, maybe you're running your fridge. Your fridge is 100 watts or 0.1 kilowatts, right? And you run that your fridge for 10 hours. Now the demand of your fridge, the capacity of your fridge is 0.1 kilowatts, right? And then you run that fridge for 10 hours. You will also consume 1 unit of electricity, right? So this is what the utility wants. They want you to lower your demand and spread it. They don't want this high demand. Now the thing is this, you can run this with I pass my neighbor generator, right? You can run this, you can power this load for 10 hours with I pass my neighbor generator. Okay, but you cannot. Now look at it, they're both 1 unit of energy. Both of them are 1 unit of energy, but this one was consumed in 1 hour, whereas this one was consumed in 10 hours. The utilities want this. They want you to maintain a lower demand and spread your consumption. Okay, so that is what demand charge is. So utility can say, okay, if you use 1 kilowatt, I'm going to charge you. I'm going to charge you for this 1 kilowatt. If you use 0.1 kilowatt, I'm going to charge you less. So it is not up to you. If you want to add so many loads to your consumption, if you want to speed up your consumption within 1 hour, it is up to you. But the point is that I'm going to charge you. Despite charging you for this energy, I will still charge you for the demand. I want you to understand how they use this to control you. So instead of owning your fridge, your washing machine, your air conditioning system all at the same time, you can say, okay, look, while I'm running my air conditioning system, let me not run my washing machine. If I off my air conditioning system, I will not run my washing machine. By so doing, you maintain this. You spread your consumption. But if you run your air conditioning system, you run your washing machine, you run your fridge, then you will have this. Then the utility company will penalize you for running everything at the same time. Because when you're running everything at the same time, what it means that they will have to build a higher capacity of generator to support this your load, right? So because they have a limited capacity of generator, And if you make them to build a very high capacity of generator, what guarantee do they have that you're going to keep on consuming 1 kilowatt? Because you can just consume this 1 kilowatt, and in the next 5 or 10 hours, you're consuming only 0.1 kilowatts, meaning that they will have excess capacity, staying redundant, doing nothing, right? So they want to limit your consumption to the capacity of their generator. And that's why they will put a charge, on your demand. I don't know if this is well understood.
Yes, it is.
Okay.
Yes, it is.
Okay, very well.
One question. So
Okay.
does the utility company, do they take time to explain this to the consumers?
Now, for the fact that it is not applicable in Nigeria yet, there is no consumer sensitization on this. But in every advanced country, if you go to US, if you go to Europe, if you go to Australia, if you go to every other advanced country, this is the standard practice. And there is no way, this is personal opinion, there is no way you run an efficient electricity industry without this. So we will get to this.
All right, thank you.
We are going to get to this eventually. Okay. It is a penalty for low power factor. Can you hear me?
Yes.
Okay. So it is a penalty for low power factor. Now, energy meters measures the real power, whereas useless reactive power is unaccounted for. Now, there's a diagram that I need to explain this. Now, what the electricity company is pushing into your house is kVA, kilovolt ampere. This is what they're pushing into your house. It only becomes kilowatts based on your consumption. So if you have electric boiler in your house, electric heater in your house, 100% of this becomes 100% of, so it becomes 1. Your power factor becomes 1. So what they're selling to you is an apparent power. Those of you that were in the previous training, you won't have any problem understanding this. What the utility company is pushing to you is voltage and amperage. The voltage and amperes, that's what they're pushing into your house. What converts this into active power is the amount of the kind of load that you give to it. And this is and the only factor that transforms this to this is your power factor, right? So if you have a low power factor, what that means that they will push more current, ampere, to fulfill your demand, right? And your meter is measuring active power. This is what your meter is measuring, not this. Now, this passes through your meter, you consume this, but your meter recognizes this. All right? So they want to make sure that you maintain a good power factor so they are not losing money. Now, I try to explain that with this diagram, this triangular diagram. A lot of us should be familiar with this, okay? Now, this is kVA. Now, this electric power that is moving upward direction, okay? Your reactive power, this kVAR, this is the reactive power, is pushing it up. Meanwhile, it should have traveled this direction. It should have traveled through this red line direction. But because you have a poor power factor, this cos pi here, or cos theta here, is what we call the power factor. So your power factor will now push this one up so that it will not travel a longer distance. This longer distance is a waste of energy. If you're using a heater, an electric heater, then this your blue line will just collapse. This will become 0. Your blue line will collapse to the red line. Then you're fine. You will notice that this blue line is longer than this red line. So the excess of it is wasted. And that's where reactive power comes in. If you're using an electric motor for the industries, you have a lot of this. So the utility company expect that you install what we call capacitors. That's what we call capacitors. Capacitor is an equipment or is a tool that used to correct this poor power factor. Okay. They expect that if you have a poor power factor, you have to install capacitors to correct it. If you don't do that, it will amount to loss of money to them. So I just use this diagram to explain what power factor is and how it affects utility company, how it affects their revenue. Okay, and that is why they want you to keep a good power factor. If you have a poor power factor, they will charge you for it. You pay for it. Now your meter can detect when your power factor is poor. Okay, so they will use it to penalize you. So if you keep paying for a poor power factor, it only makes sense for you to correct, your power factor, and then so that you don't get penalized. So I'll just read what we have here. Now it is a penalty for low power factor. That is power factor penalty or power factor penalty. It is a penalty for low power factor. Now energy meter measures real power. Now this is real power. This red one. That's what your energy meter measures, right? Whereas useless reactive power is unaccounted for. Now this is reactive power. It's useless. I should have included the beer analogy here. For those of you that attended, you understand what I mean using the beer analogy. When you pour a beer into a glass cup, you see some foam. Those foams are like the wasted beer. Okay. Yeah, but when you're paying for both the foam and the real liquid beer. Okay, that's just an analogy anyway. Okay, so this KVAR is useless. It does not do any meaningful work. But someone has to pay for it. The utility company doesn't want to pay for it, so they will make you pay for it if you don't correct your power factor. That's the whole essence of power factor penalty. In Nigeria, yet it is not. We have the utility company has a power factor that it has to maintain, but we don't have this penalty yet. Like I said, our utility company is still growing. It's still in a very nascent stage. We will get to that point when the market becomes matured, when all of this will begin to surface. Okay? In our regulations, distribution code, transmission code, there are provisions for the power factor that should be maintained. Okay? But in our tariff design, there is no penalty for that yet because our market is still growing, right? So
excuse me, Chairman.
Okay.
So apart from electric motor, which other kind of equipment generates this reactive power?
So basically, mostly inductive load, which is basically the electric motor. That is primarily electric motor that introduces this poor power factor, because when the motor is rotating, there are magnetic elements, that the electricity is being converted into, that does useless work. Okay, so that's how those power factors are being induced. So, but to correct it, you have to install capacitors. Okay, so that it kind of corrects the impact of the power factor. We discussed this more extensively in the previous training. Maybe if you look at that video, because there I give examples of different kinds of load. We have the inductive load that offsets the power factor. Then I talked about the capacitive load, that actually corrects them. There's one other load. Okay, the resistive load, that is the electric heaters and all of that. Those ones, they don't have any impact in your power factor. Okay.
Right,
so basically, primarily, it's electric motors that induces poor power factor because of the magnetic coil that they have.
Maybe that's explain why capacitors are installed in fridge motors.
Yes, exactly. Okay, so how are they being penalized? How are they charged? So there is the utility propose a fixed power factor rate. Less than that, they will fine you. So if the utility have said that, look, we want you to maintain a power factor of 0.85 or 85%. If you go below 85%, they will penalize you, and this is how they will calculate your bill. Okay, how do they calculate the amount they're going to penalize you? So they're going to check your demand charge. Okay, your demand charge is the highest peak in your consumption profile. I know I have some demand profile down in the subsequent slide, but I'm just trying to give a brief explanation of what that is. So if based on the previous example that I gave, if you look at this load, assuming you maintain this consumption for the whole month, then your demand charge will be 1 kilowatt. That's your highest demand at a particular time. So this is what demand is. So this guy now, for this guy, your demand is 1 kilowatt. Whereas for this guy, your demand is 0.1 kilowatts. Okay. So they multiply your highest demand, okay, times the accepted power factor that they want, divided by the measured power factor. That is the power factor that your meter is. So if your meter is reading 0.7, this power factor here will be 0.7. By the time they execute this calculation, they will now arrive at how much they're going to bill you for the wrong power factor. There's an example, so don't worry if you get it twisted here. There's an example where but please, you might want to write down this formula. You might want to write it down because I don't know if it's still, so you can reference it when we're doing our calculation. So this is 0.85 is the permitted power factor, whereas that it varies across country. I think Nigeria is about 0.85 or so. I'm not so sure, but I think it's there about. Most countries are about 0.85. So if it goes below 0.85, ordinarily you should be penalized. Okay. So let's proceed. Now, demand ratchets. Now, this appears as a ratchet clause in your bill. So this is bill demand for any month. Now, ratchet clause is bill. This billed demand for any month is a percentage, usually greater than 50, of the highest maximum demand of the previous 11 months or the actual demand, whichever is better. Now, let me explain this. Remember, I said that the utility company can bill you based on ratchet clause. They can also bill you based on your maximum demand or your demand charge, right? Now, I have explained what the demand charge is. Now, the demand charge is this. If this is now, this is for 1 year. This is January to December, right? But assuming that this is for 1 month, just forget about this January. Assume that this is for 1 month. All of this demand profile is for 1 month, right? And the utility company wants to bill you based on demand charge. They're going to bill you based on this 1,800 kilowatts that you consume. That's what they're going to use to bill you. So if they are going to bill, if the rate is maybe $5 per kilowatt, $5 per kilowatt, they're going to do 1,800 times 5. That will be your demand charge. If, for example, if the demand charge or if the demand rate is $5 per kilowatt, and they want to bill your demand charge, for this customer, assuming that this profile is for 1 month, they're going to charge you 1,800, which is your peak demand, times 5. And that will become your demand charge for that month. Okay. Now, let me explain what the ratchet clause here is. Remember when I was talking about the previous example where you have your air conditioning system and you have maybe your fridge running and all of that. And I say you can run your air conditioning system for 1 hour. And maybe for the entire year, you never use that air conditioning. Because you use that air conditioning for 1 hour, you send a signal to them that, look, they need to increase their generation. Hello, can you hear me? Can you hear me?
It started breaking small, but I think you can hear it now.
Okay. I noticed that the network was a little bit, that's why I needed to confirm if you can hear me. So now they don't want you to use high amount of load at one particular time, and for the rest of the period, you're using a very small load. It does not send a good signal for them. Now, look, this is how it works. Imagine that you have 500 kVA generator, 500 kVA generator, because you want to use it to power your air conditioning system. Maybe you have like 3 air conditioning systems in your house, therefore you buy 500 kVA generator. And then you use that 500 kVA generator for only one year. No, sorry, not 1 year. You use it for only 1 day. 500 kVA generator, because you want to power your air conditioning system. For the rest of the year, you're not running those air conditioning systems. It does not make economic sense for you to have buy 500 kVA generator. Right? So that is what the utility is trying to make you avoid as well. For the fact that you're taking this electricity from the grid, does not mean you should begin to use electricity anyhow. You should just add load anyhow, right? So what ratchet clause is that if you use high demand for any particular month within 12 months, within the whole year, so they go and look at your consumption for the whole year and they look at your peak demand. If your peak demand is 1,800 for one particular month, even if in your next billing cycle, maybe in your next year billing cycle, you use only 1,000, right? What ratchet clause says that I'm going to bill you based on this your highest peak, but maybe I'm going to charge you based on 80% of it. I will not charge you 100%. I can charge you maybe 80% or maybe 70% of it, even though you did not reach that peak. But for the fact that you touched that peak, I will begin to charge you on it. I don't know if it's clear.
Yes, it is.
So now the difference between ratchet clause and demand charge is this. For demand charge, it is per month. If you use a very high peak for the month, they will charge you for that demand for that very month. Okay, for only that month. So for the next month, if you use a low demand, they will charge you for that low demand for that month. But for ratchet clause, it's even worse. If you touch a high peak for 1 month, okay, for the next month, even if you use a low demand, they will charge you based on your previous high peak. So that's the difference between ratchet clause and demand charge. Someone asked that question. I hope it's clear now.
Yes, it's clear.
Okay. So
Thank you.
ratchet clause, they usually state it in percentage. They can say 70%, 80%. Like here, it's usually greater than 50%. It is usually greater than 50%. So if you use, for example, if you use 100 kilowatts in January, okay, and the ratchet clause said that they're going to charge you 80% of your peak demand. Even if you use 10 kilowatts in March, they will charge you 50% of 100 kilowatts, or 80% rather. If the ratchet clause is 80%, they will charge you 80% of that 100 kilowatts. So they will charge you 80% of 100, which is 80. Meanwhile, you only use far less than that, but they're going to charge you based on that. The whole idea is that they don't want you, I keep saying it, they don't want you to keep adding so many loads to the grid at the same time. It is good you spread your consumption. That's what they want. They don't want you to concentrate your consumption in one particular time, and every other time you have a very low consumption. They don't want it. And that is why they use some utility, they use time of use. Time of use. So at night, they will charge you less. The tariff becomes less at night. What they actually want to do is that they want you to move some of your consumption from the daytime, when a lot of people are consuming energy, to the night time, when less number of people are consuming energy. That is the whole essence of time of use tariff. We are going to talk about it anyway. So now we're going to talk about electricity rate structure, okay? How do they structure all of this? Remember, I talked about time of use. This is where we begin to talk about time of use. So the first, now each utility has different rate structure or tariff for different types of users, such as residential, small commercial, large commercial, industries, farm, irrigation, and outdoor, whichever, I mean, they have different kind of tariff. If you look at the tariff that we have in Nigeria, we also have different customer categories. However, what we have in Nigeria is flat tariff. That's what we operate in Nigeria. Okay, it is flat. So if you're an industrial consumer, they charge you per kilowatt hour, they charge you per energy. There is no demand charge, there's no ratchet clause, there's no power factor penalty. It's just a flat fee that they charge you. However, there is also a tax component. So they charge you VAT, which is 0.75. Okay. But in terms of the energy calculation, it is just a flat fee. So some people use this flat rate, which is what we use in Nigeria. So flat rate, as the name implies, is a single rate which does not vary. Each kilowatt hour costs the same, regardless of how much electricity is used or when you use them. So this is what we use in Nigeria. It's just a flat rate. In your houses, in your residential apartment, it is a flat rate. So I think the rate for us here in Abuja, I think it's about 40 something, about 47 or 40 something. So it is easier for me to calculate. In a month, I will just look at how much kilowatt hour I have consumed. I will multiply it by this rate, and then include the tax component, and I have my electricity bill. That's as simple as it gets. Now, There are seasonal rates. For some of you who has been to other countries where you have different climatic situations, you know.
Sorry, Chima.
Sorry, please, can you take that again, please? Regarding the
Yeah.
flat
Which one?
rate.
Yeah,
The
that
last part.
flat, let me just add a question, then you
Okay.
can also take it again. Now, that somebody told me that if you have three-phase, the charges for three-phase and single-phase is different. But now you're talking about flat rate. Is it how it is?
Yes. So when I spoke about flat rate, it does not mean that all consumers are classified the same. Like I said, we have in Nigeria, we have tariff categories in Nigeria. But whichever tariff category that you belongs to, your utility bill is flat for whichever category you belong to. So if you have three-phase, if you're on a three-phase, if you're a three-phase consumer, your category is different from a single-phase consumer. If you are an industrial consumer, your category is different from a commercial class consumer. Understand? However, whichever category you belong to, your tariff remains the same. I mean, it remains flat. Flat in the sense like it's simple to calculate. Just check the amount of electricity that you consume for that month in terms of kilowatt hour, multiply it by your energy rates. You have your tariff straight ahead.
Mm-hmm.
There is no demand. There is no demand charge. There is no power factor penalty. It's just a flat rate. That's why it is flat. From January to December, it is the same. Irrespective of when and how you consume the electricity, it is the same. So they don't penalize you for putting so many load at the same time, for owning all your load at the same time. They don't penalize it. It's the same. Just so if you run your air conditioning system, your washing machine, your refrigerators in 1 hour, and I run my own in 10 hours, we are paying the same tariff. They're not going to charge you for demand charge. Whereas if it's in other places where there is demand charge component, you're going to pay higher.
Okay.
Okay, so that is it. So that's why it is flat rate. So we have the seasonal rate. Now, the seasonal rate, you know, when you're in summer in other countries like Europe and America, okay, consumption varies. So maybe when you're in summer, it could be that during winter, because winter is the cold weather there, and during winter, there's a lot of heat going on. So it could be that during that winter, there's high amount of energy consumption. And for the utility company to supply you that high amount of energy consumption, they need to buy extra capacity, okay, to be able to meet up that demand. So they will charge you different tariff for that. Whereas during summer or during spring, there is lower amount of energy consumption. So they will not contract some additional capacity. Now, there are people that provide additional capacity to the utility. So sometimes we call them ancillary service providers, okay? So you can have your own generator. During high demand, I can call you, Engineer Peter, please, I need your generator to come in and augment the demand of my customer. I can sign a contract with you to use your generator for that period. After that period, our contract expires, I will leave you. So because I'm contracting additional capacity to be able to supply your high demand during winter and during summer, I'm going to charge you for it. That's why you have different tariffs in those kind of countries. So you have seasonal rates. During winter, you have a different rate. During spring, you have a different rate. During summer, you have a different rate. Okay? So this is the reason why you have seasonal rates. So some people do that. Whereas in some other places, we have what we call tiered or block rates. Okay? Now, block rate is this. If I consume 100 kilowatt hour of electricity, now the block rate can be inclining, it can be declining. So if you're consuming high amount of energy, it could be that the higher you consume, the lower your tariff becomes. So the utility company wants to consume more energy, but they don't want you, they want you to consume it reasonably. In the sense, they don't want you to mess up your demand profile. You can maintain 100 kilowatts or even if it's 1,000 kilowatts, but maintain it to be consistent. They like it that way. They don't want you to do 1,000 kilowatts and in the next month you're doing 200 kilowatts. No. They want you to maintain it to be consistent with that, your demand, but they want you to consume higher amount of energy. So it could be an incentive for you to maintain that your high consumption, right? So they can give you a tariff discount. So the higher you consume, they can reduce your tariff a little bit, just so that you can maintain your higher consumption. Whereas in some other places, it could be that the higher you consume, the more you pay. So these are block rates. Okay. They classify the consumers according to their consumption for the billing cycle. I don't know if that's clear.
Yeah, it is.
Okay. So now there's another one that's called time of use. I explained this a little bit the other time. So there's a time of use rate. Now this time of use is basically during the night time. They want you to consume your electricity during that night, because during the night time, most of the industries are not running, but they want their capacity to remain high. So they will now give a kind of a discount. So your rate during the night will become low. Okay. So what that does for you as a consumer, this is where you now begin to do load shifting. There's a concept called load shifting. So for example, now, if you want to do your washing machine and the tariff during the day is high, maybe they're charging you, maybe for example, 15 naira per unit of electricity during the day. And then at night, they will charge you 30 naira per unit. It only makes sense for you not to run that your washing machine during the day. Then you wait for night. When the tariff is low, you run your washing machine. What they have done is actually they have controlled your behavior so that you don't use that your washing machine during the day and then use it at night. So it is a win-win for both of you. For the utility company, they don't need to go and contract additional capacity, because it could be that if more people are using this energy during the day, they will need to go and contract additional capacity to be able to meet up with the demand. Okay, and they don't want that. So they will now say, okay, during the night, instead of us running at a low capacity, let us incentivize these consumers so that during the night they can use this load. So that is the whole essence of time of use rates. So the last one here is the real-time pricing. Okay, real-time pricing. Now we know all the components that makes up the electricity tariff, the electricity rates. Now we know that sometimes these things can vary. The price of fuel can change, right? So I can put my tariff rates at maybe, for example, 14.
Oh, that yeah, 3:30 are closing. This is 1 hour later. So
I need to please please mute yourself if you're not speaking. After this, we'll go for a short break. After this slide, we'll go for a short break, a 10 minutes break. So I'm trying to explain real-time pricing. Now, real-time pricing is such that because of the variation in some of the components of your bill. So for example, the price of your fuel. Remember that Nigeria, we can change the price of fuel anyhow. Maybe you have calculated your tariff for this month with using the price of maybe 160 naira for the price of a liter of diesel. And just 2 days later, the government will now come and change the price of diesel, the price of petrol to 165 naira, right? If that happens, there are ways which the utility company can actually get back their money from the consumers. So one of them is the real-time pricing. So as government change the price of their fuel, they will just automatically also change the price of their electricity rates, right? So it is real-time pricing. If anything changes, they will change it immediately. They will not wait for tariff review. They'll just change it immediately. That is real-time pricing. Is that clear? Hello?
Yes, Chima, it's clear.
Okay. Please, I think let's just take a 10 minutes break. We should be back by, this is 4:38 now, so we should be back by 4:48. Then we can now proceed with sample examples. We can now do some calculations and then proceed with some other things. There's a lot that we need to cover. So when we come back, I will be a little bit faster. So we're going to come back at 4:38. 4:38. So 10 minutes break, please.
Now is 4:39.
Okay, so let's come back at 4:39 then.
It's already 4:39, sorry.
No, sorry, I'm getting this mixed up. This is 4:39, so we are coming back at 4:49.
Okay,
Yes.
better.
Okay, so 4:49, 10 minutes break. All right. Please get your calculator around. If you don't have it around, we're going to do some little calculations. All right, so the break starts now.
Okay.
Okay, so we have an example before us here. We need to calculate. The question is asking us to find the cost of the electric bill for the month. And here are the details. So here is the rate or tariff structure, charges per month. Now for this tariff, there is a customer charge, which is the same thing as a service charge of $50 per month. This is fixed, right? Then there is an energy charge of 0.09 per kilowatt hour. So depending on the number of kilowatt hour that this person consumes, we multiply by this to get the total energy charge. Then there is a demand charge, okay? For every kilowatt that this man adds to his consumption, he's charged $8.5 per kilowatt. So if he keeps on increasing his kilowatt, his bills keep on increasing by this rate. Then there's a fuel adjustment price. Remember, I told you that sometimes you could model your tariff with a certain price of fuel, and before you know it, the price of fuel will change. So if the price of fuel change, in the course of calculating your tariff, you have to do an adjustment. So assuming that there is a fuel adjustment price of 0.025 per kilowatt hour. So in producing every unit of electricity, the fuel component price has changed from what it used to be, and it increased by 0.025. That's what it means. Then, of course, you have the taxes, a total of 8% on entire bill. Remember that in Nigeria here, VAT is 7.5, right? But in this case, the tax here is 8%. So now, a large office building receives services from its electric utility at the above general service demand rate structure, above, based on all of these criteria. Now, the electric energy use and demand for this company for 1 month are energy consumption. So this facility consumes 150,000 kilowatt hour in 1 month. And then the metered demand, the highest demand that the meter recorded was 525 kilowatts. Now the question is, find the cost of the electric bill for the month. Okay. So basically, we have to calculate different components of this bill. Okay. I just want to give a little explanation before I'll go into the solution in the slide, in the next slide. So here we need to determine the demand charge, because there's a demand charge here, and the demand charge is $8.5 per kilowatt. So we're going to multiply this 8.5 by this metered demand, 525. Okay. So if we multiply it, then we now have our demand charge. Then we calculate our energy charge. We are going to do, this is energy consumption for the month, 150,000, right? We're going to multiply this 150,000 by this 0.09. Now, there is also another component to this energy charge, which is the fuel adjustment price. So we're going to add these two together, 0.09 plus 0.025, because they're both energy charge per kilowatt hour per kilowatt hour. They are both energy charge, right? Now, this is fuel adjustment, but you have to add two of them. So when you add this plus this, okay, you multiply by 150, right? To get the energy charge plus the fuel adjustment. Then you now have to do the tax. You now introduce the tax rate. I'm just trying to offer a brief explanation so that when I show you the example, it becomes a bit clearer, because while I'm showing the example, this question will disappear, except if you want to have the screenshots to keep remembering these questions. Okay. So of course, when you're done doing all of those things, you now add this your fixed charge. This is fixed. You now add $50. When you're done doing all of those things, you multiply by your 8%, which is 1.08. Now, let me show you the solution. So here is the solution. So we have the $50, which is a fixed charge, right? Plus the energy consumption for the month is 150 kilowatt hour, right? Times 0.09, which is a unit of the energy, plus 0.025, which is the full adjustment. Remember that both of these costs are per unit of the energy consumed. So you add both of them and then you multiply them by the amount of energy that was consumed. So all of this now becomes your energy charge, whereas this one becomes your fixed charge. Now, plus your demand charge. Remember, your charge 8.50 per kilowatt. So you multiply it by the kilowatts. And our consumption in kilowatts is 525, right? So I take that again. You have the fixed charge here. You have the energy charge here, plus the energy charge, plus the demand charge. All of this is what will now form your energy bill, okay? So when you run that calculation, you're going to have 21,762.50. This is what you're going to have when you calculate all of this. You're going to have 21,762.5. That's what you're going to have. Then you now multiply it by the tax factor or the tax rate. The tax rate is 8%, right? Now, this 8% is the same thing as 1.08. Remember? So when you multiply it by the 8% tax, you arrive at your final energy bill for the month, which is $23,503.50. Does anyone has any question? Is it clear enough?
Please take it again.
Okay. So this is the question that we asked. We are told that for this customer, every month, whether he consumes or he doesn't consume, he's going to pay us $50 every month for us to pay our administration and our metering service and everything. So that is the $50. Every month you have to pay that, right? Energy charge is 0.09. So for every unit of energy he consumes, we are going to multiply it by this. Every unit of energy he consumes, we are going to multiply it by this. Is that clear? And then we were told that his demand charge is 8.5 per kilowatt. So if he use, Engineer Jibril, do you have a question? Are you saying something? Okay, let me continue. So we are told that the demand charge for every kilowatt load that he adds on his consumption at any point in time, if he adds any load, he's going to be charged $8.50 per kilowatt for that very month. Even if he uses that load for only 10 minutes or only for 15 minutes, and for the entire month, he doesn't, maybe he used 10. Now, in this case, we are told that this customer used 525 kilowatts. That's what's the maximum load that he used for the month. It does not mean that for all the period in the month, he was using 522. It could be that in some of the days, he only used 200. In some of the days, he might only use 100. But there was a particular day, there was a particular time in a month that this customer used 525, and the meter recorded it. It doesn't concern us if he used less than that any other time. It doesn't concern us. Had he increased this further to maybe 600, that's what we're going to use. It doesn't concern us if he uses 200 or if he uses 100 any other time. That is the demand we want to know. For the fact that you've touched that high demand, they're going to charge you for it. So for this customer, he uses 525 kilowatts. That's his peak ever for that month. So we're going to multiply this peak, this is 522, by the rate, demand rate, or demand charge, which is $8.50. If we do that, we can keep that aside. Okay, let me walk us through this example. Okay, I'm assuming that we all have our calculators. So let us first of all calculate the demand charge. So please let us do this together. The demand charge is $8.50 times Now $8.50 times 525 kilowatts. Can we check what that is? Can we do the calculation? Someone just punch a calculator and tell me what that is.
4462.5.
4462.5. That is dollar.
Yeah.
So that is our demand charge, right? Now let us calculate our energy charge. So our energy charge would be 150,000 times 0.09. So can we do that calculation and then see what that gives us? 0.09 times 150,000.
I thought
give me,
I thought we will add the fuel adjustment.
Yes, we can add it now. We can do it separate. So I don't want us to get it confused. So I wanted to do it separately. Okay. Okay.
Yes, do it separately.
Yeah, exactly. So someone should tell me what the value is.
$13,500.
$13,500. That's our energy charge. Now let us calculate our fuel adjustment price. Now our fuel adjustment price is 0.025 times 150 units of energy. So let us calculate that as well. 0.025 times 150 units. What do we get?
We have 3,750.
3,750. Now remember that our fixed charge is equals to $50, right? $50 for the month.
Yes, the customer charge, fixed charge, yes.
Exactly. So let us add all of these costs together. So we're adding the demand charge plus energy charge plus fuel adjustment charge plus the fixed charge. Let us add all of this together and then check what we get. What do we have? If you have an answer, let me know. What do you have?
I have 21,762.5.
Exactly. So that is the cost for the month. Then remember there is a tax component. So we're going to times that by 21,762.5 times 1.08. That's 8% of that amount, right? So can you do the multiplication and then tell me what you got?
Okay, multiplied by 0.8%, all right?
1.08. That is 8%.
Okay. It will give 23,503.5.
So that is the total bill that this customer needs to pay for the month. You see how we did it? We calculated the demand, we calculated the energy, we calculated the fuel adjustment, and then we added the fixed charge plus the tax. This is how to calculate energy bills. There are different components to calculate in energy bill. Okay, so this is the solution this is the answer that we got. We got the same thing, right? Is this solution clear to everyone? How we calculated the demand, how we calculated the energy, how we calculated the fuel adjustment, and then of course, plus the fixed charge, and then the tax. Is that clear to everyone? If anyone is confused.
So sorry,
Yeah.
the only last. Let me see. That tax, that 8% that we used 1.08. I'm trying to find out how we got 1.08.
Okay, so if alternatively you can calculate 8% of this, you can calculate 8% of this amount. You can say 0.08 times this amount, then you add it to this amount again. You get at this, you arrive at the same price here.
Okay. Let me see. Okay. I think I was not even looking at the screen. Okay. Let me do that now.
This is just a shorter way to do it. So calculate 8% of this. So 0.08 times this amount, you now add it to this amount again. But that might be a long, so I mean, just for a short way to do it, just it's 8% higher than 100%. That's what it means. Are you there now?
Sorry, I think I missed something.
Okay.
Sorry. Yes. 8%, that's 0.08.
0.08
times 21,762.
Yes.
It will now give me 1741.
1741. Add it to this 21,762.5.
Okay.
Are you there now?
Yes. Yeah, it actually gave 23,503.5. It's clear.
Exactly. Okay. So good that we're all on the same page. I think I will leave you to do one exercise. So this is exercise. So now for the same question that we have, okay? But in this case, watch carefully. See the changes that I've made. Now, instead of demand, right? I've added ratchet clause, and the ratchet clause is 70%. And his annual peak demand is 900. Now, let me explain this. In this case now, you're not going to be making use of your demand charge. Okay? I mean, sorry, you're not going to make use of this 900. You're going to check 70% of this 900. It becomes your demand charge. I mean, it becomes your demand for that month, not your demand. It becomes your demand for that month. Then you multiply it with this demand charge. So can you try your hands on it? I'll just give you like 2 minutes to do this. Then we'll solve it together.
Please, I think you should.
I should solve it?
No, rewind. No, I didn't say should. Yeah. I was doing this calculation, so I'm through with that calculation. So please rewind what you just said.
Okay, this is just an exercise that I want you to try your hands on.
Okay.
Everything remains the same. Only that this one I have introduced a ratchet clause, and my ratchet clause is 70%. And then the annual peak demand. This one is not a monthly. The annual peak demand now is 900 kilowatts. And I'm using a ratchet clause of 70. So I'm just giving you a hint. If you want to calculate your demand for this month now, you're going to use 70% of this 900.
Okay.
It will now become your demand for the month. So that is a hint that I just gave to you. Then every other thing that we did in the first time, you repeat it. So just try your hands and let's see what you get.
So just one question, Chima. I remember you mentioned when we did the explanation that we can either use the demand or the ratchet clause. So
exactly.
Whichever one. So which one we're going to use in this case?
So I want you to calculate for the for ratchet clause. Use ratchet clause to calculate for here. Okay. Now, after you've done calculating with ratchet clause, maybe in our others, if you get it correct, I will not need to solve it again. Then I will now solve using demand charge. I will not use ratchet clause. So we cannot compare which one is higher. Anyone that is higher for the utility, that's what they're going to choose. Is that clear?
So are you saying
Yes.
we should ignore the energy consumption and
No, you're calculating the bill for the customer for the month. And the bill for the month comprises of the demand for the month. It comprises of energy consumption for the month.
Okay.
It comprises of fuel adjustment and then the tax, right? But I'm not saying for you to calculate your demand for this month, you're not going to use this 900. Because this 900 is the consumption, is the peak demand for 1 year, not for the month. So it could be that his demand, it could be that for that month, his now remember that this customer for the month he consumed 525. That was his demand for the month. Are we clear? Are we clear?
Yes, okay.
Yeah, his demand from the previous example is 525. But his annual peak, I mean, over the year, the highest demand he has touched so far is 900, and we want to penalize him for touching that 900. So we are introducing ratchet clause.
please can you just go a little bit back on the what we have done and come back again?
This question or the solution?
Okay, this is what we have done. Okay,
Yes.
come back again, go back again. Okay.
So I have just added the monthly, the demand for the month, which is 525. However, his annual peak is 900. So sometime in the year, he has touched 900. So in that case, we are now introducing the ratchet clause. So just try your hands on this solution.
Okay. Okay, this one.
If anyone arrive at an answer, please let's know. I still got 2350 3.5. You still got the same thing that we got in the previous one. Then you didn't do the ratchet clause. Now I gave you a hint. I said the ratchet. Okay.
Yeah, I didn't do the ratchet. Let me add it. Sorry.
No, the ratchet clause is 70% of 900. That's what you're going to use. You're not using 525 in this time.
Okay, I got it.
The only thing that changes in this solution is your ratchet clause, which is 70% of 900. Then your solution is the same thing with the previous thing that we did.
You say I'm not using the 525.
You are not using 525. No.
Going to use 535.
We are using ratchet clause for this time.
Okay. Okay, I see what you mean. Okay.
Okay, so I got 19,364.4.
Yeah, that's what my own I arrived back now.
You got what?
19,364.4.
So here is the solution.
Sorry, before you drop, because I got 552, 800 for.
Now let us solve it together.
Everything together.
Let us solve this
added
together, because you're getting different things, and none of you has gotten the answer correct. This is what the answer actually is 24,467.40. Did anybody get this?
0.08 equal to.
Did anybody get this?
44,224.
The final answer is $24,467.40.
Okay.
Did anybody get this?
No, I didn't get that.
Okay.
Nobody got it. Okay.
Yeah,
so let us do it.
Yeah, mine is like that.
Did you get it?
Yeah.
Then.
Ratchet
Okay.
So what's the mistake now?
So just look at it. In this case, your ratchet clause is 70% of the 900, which is 630. That's why I say you're not using 525. You're using 630 instead this time around.
8%.
Okay.
Kilowatts.
Okay, that's what I have now.
Have we all gotten the answer to 24,467.4? If anyone is still lost or you still don't understand, please let me know so I can walk you through.
Yeah, where do you have the 8.5?
The 8.5 is the demand rate, demand charge per kilowatt.
And it's based on that ratchet, or what do you call it?
No. Now the demand charge is $8.50 per kilowatt.
A month. Okay.
Right. So now for you to determine your demand for the month, if you're using the ratchet clause, it's going to be 70%. So your ratchet clause is 70% of your maximum peak for the year, not for the month. And I say that because this customer, at some point during the year, he has touched 900. He was careless about his consumption. He now touched 900, but for this month, he only used 525. But we don't care about this 525. We want to penalize him for touching 900. We're not introducing a ratchet clause. So when you introduce a ratchet clause, instead of calculating his demand at 525, you will now use 630. You now times it. You now times 630 by the demand rate.
Yeah, but my understanding was that we either use the ratchet or the demand, whichever one is higher.
Exactly.
And I asked you before we started the calculation. So my understanding was that, okay, we'll do with only the ratchet, and then you said we'll do with the demand later. So I didn't include the demand at all. That's why I arrived at 19,364.
Okay. So I understand where you got it twisted. So the ratchet is only a means for you to determine his peak demand for the month. It does not change anything. It does not change how you calculate the demand charge.
Okay.
It only changes how you arrive at your demand for the month, your peak demand for the month.
3.09.
So you can either use the meter reading for the month, which is 525, which is what we calculated previously, or if you're using a ratchet clause, then you're using 70% of the all-time peak for the year, not for that month.
Yeah, okay.
I don't know if it's clear. So for this very customer, if we use the normal demand, this is his bill. If we use his normal peak demand for the month, his bill is 23,503. But because sometime in the year, he has cost 900 kilowatt, which is what we don't want. So if we look at the normal calculation, it's giving us 23,005. But if we now introduce the ratchet, it's giving us 24,004. If I am the utility company, I will use ratchet for him. I will bill him based on ratchet.
Okay.
Because the ratchet is higher.
Adding on.
All right.
Did you understand that now?
Yeah, it's clear.
Yes.
So I have to multiply it.
500.
I think some of you are still trying your hands on the calculation. Is it okay now? Have you arrived at 24,467.4 and you understood how we got that? So let's continue. I mean, you can always play back the video if there's any point you missed or you're not very clear, okay? This is an example too, okay? This is a cost of a 30 minutes mistake. Now, a production facility has 4 large machines with a demand of 200 kilowatt each. Now, each of these machines has a demand of 200 kilowatts. And you have 4 of them in a production facility. So meaning that if 4 of them are on at the same time, you're going to have 800 kilowatts, their demand. Okay. Now, because they don't want to hit that 800 kilowatts, now the machine could be controlled by a computer, which will limit the total demand to 400 kilowatts at any one time. They don't want to go more than 400 kilowatts because if they go more than that, they'll pay more. So they want to operate only 2 at a particular time, right? Now, this company limits the use of the machine by operational policy, which says that no more than 2 machines should be turned on at any given time. Now, the reason for this is because they want to control their demand. They don't want to pay unnecessary demand charges. Now, the room is separately metered from the rest of the facility. So these 4 machines are separately metered. There's a meter going into this facility that has these machines. And the other loads are very minor. So they have just other loads that are minor, okay? Now, one morning at 8 o'clock, a new employee turned on the 2 idle machines. So 2 machines were running already. One new employee just came in and then turned on the other 2 idle machines without knowing the company's policy. He did this at 8 o'clock. So what that means that at this time, the company is running at 800 kilowatts, right? So the 4 machines are running. And the company never wanted to exceed 400, but because this guy is a new employee, he didn't understand the whole process. He now went and turned in other 2 idle machines. So all the 4 machines started running. So at 8:30 a.m., the plant's foreman or the person who oversees the operations of the plant noticed that too many machines were running, and he quickly shut down the extra 2 machines. What did this mistake cost this facility? Now, this is a typical certified energy managers exam question. That's where I got this from. Okay. Now they want to know what is the cost of this mistake to this company. Okay. What mistake is that? The running of 2 machines for 30 minutes because he started this machine by 8 o'clock and by 8:30 it was turned off. So what is the extra cost of running additional 400 kilowatts for 30 minutes? That is what this question is asking us. Okay. Do we understand the question? Because as I was reading it, I also take time to explain the scenario. Do we understand the question first of all?
Yeah, I think I do.
You understand the question? Okay, fine. So let us look at the solution, right? The immediate cost of this thing. Now, the immediate cost on the month's electric bill has 2 components. two components. Remember, there is a demand charge, there is energy charge. And those are the two components. For the fact that he ran this machine for 30 minutes, we are going to calculate the impact on their demand charge. You know, they wanted to maintain their demand limit to be 400, right? But this man now has come and increased it to 800. So that additional 400 will now be multiplied by their demand, irrespective of any time during the month, right? So we are going to calculate their demand based on 800, not on 400. And then we're going to calculate the energy consumption of that machine for 30 minutes. So I'm just trying to explain what the solution is before I begin to explain what I have on my screen. So now the immediate cost of the month's electric bill has two components, including sales tax. Assume a demand of $6.5 per kilowatt for the month plus 8% tax. Okay, that's monthly tax of 8%. Now you can just ignore this. Okay, now this 7.02 is the 8% tax on this. Is the 8% tax on this $5.5 per kilowatt for the month. Now let's not get confused about this. There's something that is omitted here. This 6.5 should have been multiplied by 400. Then you now take 8% of it. Hello, are you with me?
Yeah, we are trying to understand you.
We're not.
Okay. Now, this is what we're going to do. We're going to solve that question. Forget this example. Forget what you're seeing on. Let us solve it. All of us are going to solve it together. That way, we understand better, right?
Okay.
So here we go. Now, there are different charges that this guy has introduced by running this machine for 30 minutes. Now, one of them is that he ran this machine, which is 400 kilowatts. Let us calculate the energy charge, extra energy charge that he has incurred for this company, right? So the machine, both of them are 400 kilowatts altogether, 200 for each of them. Two of the machines is 400 kilowatts. Is that clear?
Yes.
And he ran that machine for 30 minutes. That is half hour, 0.5 hour, right? So let us multiply that. 400 times 0.5. What do we get?
200.
That is 200 kilowatt hour additional energy cost for that company, right? Now that 200 kilowatts hour, multiply it by the energy charge. Now let me see what the energy charge is here from the solution. The energy charge is still the same thing with what we have in the old solution, which is 0.09. Okay. Now let me add the full adjustment. Or do you want us to do it separately?
Let's do it separately so that we're following it step by step.
Okay. So now the energy cost is now 200 times, that's 200 kilowatt hour times the unit of energy, which is 0.09, right? What do we get?
What by what?
We get
200 kilowatt hour times 0.09 cents. 0.09 is the unit, is the rate of energy.
That's
so we got 18, right? So now let us look at the full adjustment. So we're going to do another one. 200 kilowatts, that is for energy. Let us do the full adjustment, which is 200 times 0.025. What do we get?
$5.
We got $5.
Yes.
Okay. Now let us calculate the demand that this guy has imposed on this company. So instead of 400 kilowatts, he now did 800 kilowatts. So 400 additional, right? So we're going to do that 400 kilowatts times their demand rate. Their demand rate here is 6.5. Right? So what do we get? 400 kilowatts times 6.5. What do we get?
2,600.
Now 2,600. Okay. Now let us add all of this together. 2,600 plus 5 plus 18. What do we have?
2,623.
2,623. Now let us now add the tax component, okay, which is zero. This is 1.08. What do we get?
Adding the tax component?
Yes, there's tax component, yes.
2832.
2832.84. Exactly. So did you see that that's the answer that we got? That's the answer that we arrived here at 10 times. So this, for the fact that this guy came in and turned on this machine for 30 minutes, is the mistake. This mistake cost the company $2,832.84. Is it clear?
Yeah, from the
the
answer we got, but what is on the paper presentation is somewhat
on the screen. It looks, yeah, that's why I wanted to walk you through it so that we'll go through it together. It's the same thing.
Sorry, the tax component, you know, I got to 2623. That is when I added all, and you said we should add the tax component.
Yes. No, you're multiplying by the tax component.
Multiply by 1.08.
Oh, multiply.
Yes.
Okay.
Yes, sorry, not add. You multiply by 1.08.
Okay.
Yes.
Yeah, 2832.84.
Exactly. So that is the cost of this mistake of running that additional machine for 30 minutes. So now what I have on the screen here, now what happened here is that if you look at the solution that I have on the screen, I have already added the energy charge for the full adjustment price. But in our calculation, I separated it so that I don't get you confused. If you understand the way we have solved it, you also, if you look at what I have on the screen, you understand it. So here I have added the energy cost plus the full adjustment price, and I've also multiplied by the tax rates, and I arrive at this per kilowatt hour. Okay, maybe I should just delete this thing and let's just okay, hold on. See, this is what I'm going to do. I'm going to add another slide and then solve it in the way that it makes sense to you. Okay, so this is what I'm going to do. Are we together? So yes. First of all, we want to calculate the energy charge, right? Now the energy charge, now the extra energy consumption is 200, right?
Yep.
Kilowatt hour. Now times the unit of energy, which is 0.09 dollars, right? And when we did that, we got 18.
18, yes.
We got $18. Okay, so that is energy charge. Now let us look at the fuel adjustment. Fuel adjustment charge. So still on 200 kilowatts hour times the full adjustment cost is 0.025, right? And then we got $5. Then let us now calculate the demand charge. Now extra demand is 400, right? 400 kilowatts. Times the demand rate, which is $6.5 per kilowatt. So when we multiply that, what we have was 2,000.
623.
No, is this 600? 2,600. Check that.
Yeah, 2,600.
Right? So we got 2,600. Okay. So what I want us to do is.
But what we have there is 6.5.
Sorry, 6.5. Thank you. Okay. So the total. Sorry. The total of all of these charges is we got $2,000. 623, right?
Yes.
They will have a tax. We have a tax rate of 8%. Okay. So total cost of mistake will now be equals to 2,623, right? Times 1.08, which is equals to 2,832.84. So these are alternate exercise calculation. So is this better? The way I presented it now, is it better?
Yes, it's better. This is nice.
Okay. So this is just an alternate solution. But I'm sure if you also take your time to look at this previous one, you still get the way it's the solution took place there. So this is the cost of that mistake, just 30 minutes mistake, and the company is going to pay this amount of money for that. Now, the whole essence of this is to make you understand the impact of consumer behavior, how you consume your energy. How you consume your energy has a way to increase your bill. However, Nigeria, we are still not gotten to that stage where we are being charged our demand charge. By the time they begin to charge us demand charge, a lot of people will be more disciplined on how they use their electricity. So you don't just own all your equipment at the same time. It doesn't benefit the utility component by doing that. So let us go into energy accounting. I think we need to move a little bit faster so we'll be able to cover up. So energy accounting covers the following: recognizing different energy and fuel types. All of this you can reach. Let's just get into the main thing. But what I want to emphasize here is the difference between energy and power. I always say this: energy and power, they are two different things. Okay. And that's what this is also trying to explain. See, understanding energy related units. Energy is kilowatt hour. I've seen some people, they want to mention, they want to say energy, they will say kilowatts. Kilowatt is power, not energy. Kilowatt hour is energy. Kilowatt alone is power. Watts alone is power. Watt hour is energy. We need to understand this. So when we go into this, the following examples we're going to do now, you're going to understand the difference between this energy and power. It's going to become more clear. So for us to be able to convert different forms of energy, remember that energy comes from different sources. It can come from coal, it can come from oil, it can come from gas. So the question is, how do you now convert this energy from different sources to a base unit? How do you do those conversions? That's what we're going to do now, energy unit conversion. So please, I want you to have a screenshot of this conversion table, because we are going to be making reference to it. Okay, this material was also shared with you before now. So if you had a printout of it, that would be fantastic. If not, no problem. You might just want to do a screenshot. We'll always be making reference to this conversion table. If you're doing an exam, it's an open book exam. You can always come. You are not in the university days where you're expected to cram all of this. No. You can come with your interest table, conversion tables, and all of that. Even when you're doing design, assuming you're doing your design in your office, you have access to all of this. You don't need to put all of them in your memory, okay? So this is the conversion table. We're going to be making use of it as we do some of this energy conversion calculation. And I'm going to tell you the importance why we need to do this energy conversion calculations. But let us take a few examples of energy conversion first. Now, to avoid us making mistakes in unit conversion, the rail track method may be used. I'm going to explain what the rail track method is. So for example, I'm going to explain that with an example. How many kilojoule are there in 10 kilowatt hour? Now, these two things are energy. Kilojoule is energy. Kilowatt hour is also energy, but they're having different units. So if somebody gives you a kilowatt hour and is expecting you to compare it with something else that is in kilojoule, how do you now convert this kilowatt hour to kilojoule so that I can be able to compare them? Mind you, you cannot compare the two of them without bringing the base unit. That's why it's important we learn this energy conversion. Okay? Before you can make comparison, you need to bring them to a base unit. Now, this is kilowatt hour, but they're asking how many kilojoule are in. So assuming that you want to compare with another form of energy that is in kilojoule, how do you do that? Okay? Now, normally, we use a rail track method to do that. So this is the solution. Okay? How do we do that? We start with what we know. Okay? So we are given 10 kilowatt hour. Okay? So you draw a cross like this, and you draw this cross. Then you now write this 10 kilowatt hour on the top, right? Then can you go through your energy conversion table and then see the conversion factor between kilowatts? Sorry. Look at the conversion factor between kilowatt hour and kilojoule. Look at your conversion table, please. You see 1 kilowatt hour is equal to how many kilojoule? So this is our conversion table here. So you have 1 kilowatt hour here is equal to 3,600 kilojoule, or is equal to 3.6 megajoule, or 0.0036 gigajoule. This conversion to this is a factor of 1,000. If you're converting from kilojoule to megajoule, is a factor, you divide by 1,000. If you're converting from megajoule to gigajoule, you're also dividing by 1,000. Okay, so 1 kilowatt hour is equal to 3,600 kilojoule, right? That's our conversion factor. So, and that's what we're going to do here. So we'll now write 3,600 kilojoule and put the kilowatt down here so that we can easily cross them. We can easily cancel them out, right? Remember how we arrive at this. We went to our table conversion factor and find out what the conversion factor between these two is. And they would deliberately write the kilowatt hour down here so that we can cancel it. And then write the kilojoule on top, right? So once you've done this, you've canceled this kilowatt hour, you just multiply 10,000, this 10 here, times 3,600, divided by 1. If there is 2 here, assume that there is 2 here, you also divide by 2. Okay? So that is just a simple conversion. There are other ways you can do that by, if you want to do, so if you want to do cross multiplication, you can do cross multiplication, but you get a stage where it becomes complex that you cannot easily do cross multiplication. So for some of us, we can just do, okay, if 1 kilojoule is going to give us, if 3,600 kilojoule is going to give us 1 kilowatt hour, 10 kilowatt hour will be equals to how many kilojoule? You now do a cross multiplication and you arrive at the answer. Correct. But you might get to a point where it will not be easy for you to do that cross multiplication. You can easily do cross multiplication here because it's a simple solution. Don't worry, we're going to get into a more complex one. That you find out it will be difficult for you to do cross multiplication. So in this example, the 2 units cancels out. That is the 2 kilowatt hour cancels out, leaving the remaining units on the right side as kilojoule. So let us do another example. So what is the number? What's the number X of joules in 1,000 meter cube of a natural gas in gigajoule? So you want to find out the value of energy in 1,000 meter cube of a natural gas. You want to find out the value of energy in gigajoule. So you have 1,000 meter cube of a natural gas, and you want to know the energy content in gigajoule, right? How do you know that? How do you do that? Now, let me just make this simple example as well. The diesel that you buy and you put into your diesel generator, you're not buying those diesel because you love diesel. You're buying it because of the energy content. So the question could be, how many kilowatt hour are in 1 liter of diesel? You need to know how to determine all of these units, all of these quantities. Okay, so that if you now buy a poor quality diesel, what that means that you're going to get a lesser number of electricity out of it. And that is the cost implication of people who are buying poor quality diesel. Or if you buy adulterated diesel, what that means that the amount of electricity that you ordinarily get from that 1 liter of diesel will be less. So you need to have this knowledge of energy conversion, so that if somebody is telling that he's burning this amount of diesel, and as an energy consultant, you should translate that quantity of diesel into an amount of electricity. And then you now compare what he's getting. Assume that he has a meter, you now compare like, look, I think something is wrong. This is the amount of electricity that you should be getting. But looking at what you actually have, then something could be wrong. You need to have all this knowledge to be able to identify problems when you go into any facility or any company to do an audit for them or to examine their electricity process. So that's why it's important that we learn all of this conversion and their energy content quantities rather. So now back to the question. It's not asking us the amount of energy that is contained in 1,000 meter cube of a natural gas. Okay. Now remember, I said that we always start from what we know. We are giving 1,000 meter cube. So you draw your line and then you write 1,000 meter cube here. Okay. Now we have to look at our conversion table. It might not be easy for us to convert from meter cube to gigajoule straight. So let us convert to megajoule, okay, first, okay? If you have the factor to convert from meter cube to gigajoule straight, then you can go ahead, but sometimes you need to convert to megajoule or even kilojoule before you can now proceed to the final gigajoule. So if we look at our table, what is the conversion factor of a natural gas measured in meter cube to megajoule? So let us look at our conversion table. I'm trying to go back to the table. So 1 meter cube of natural gas. So this is 1 meter cube of natural gas, right? Now we are given the conversion factor in megajoule. We know it is 37 megajoule.
Yes.
Right? Exactly. Mm-hmm. So we now take this to solve that question. So remember, I told you that you have to put the unit of the natural gas below so that I can easily cross out. Then you put the 37 up, right? So we cancel this out. So if we multiply these two, we have a quantity of energy in megajoule, but they're asking us the quantity in gigajoule. So what is the conversion factor between megajoule and gigajoule? It's a question of, it's 1,000. Remember, I told you, if you're converting from mega to giga, you divide by 1,000. Is that so?
Yes.
Exactly. So yeah, we want to convert this megajoule now to gigajoule, and it is the conversion factor is 1,000. So we now put the megajoule down, so we can cross it, we can cancel it out. So 1 gigajoule is equal to 1,000 megajoule, right? So we can cancel out this megajoule, and we're now left with gigajoule. Okay. So we now multiply this 1,000 times 37 times 1 divided by 1 times 1,000. So all of this times all of this divided by the multiplication of all of this below. Is that clear?
Yeah.
Okay, so when you do the multiplication, you are going to arrive at 37 gigajoule.
Yes.
So 1,000 meter cube of natural gas is equals to 37 gigajoule. Okay, so that is the conversion for you. So let us do another example. Okay, so find the number X of kilowatt hour in 1,000 meter cube of this same 1,000 meter cube of natural gas. But this time we want to find it in kilowatt hour, not in gigajoule, right? So just the same thing that we did the other time. We have 1,000 meter cube. We first of all convert it to megajoule because that's what we know in our conversion table. And if we go back to our conversion table, we want to convert megajoule to kilowatt hour. So if you look at that conversion table, remember I said you should keep handy this conversion table. So this is kilowatt hour. 1 kilowatt hour is equals to 3.6 megajoule, right? So that becomes our conversion factor. So this is what we have here. You now put your megajoule down here so you can cancel out and then put your kilowatt hour here, right? So you multiply all of this divided by the multiplication of all of this. So 1,000 times 37 times 1 divided by 1 times 37. Please bear in mind that you're not, if you want to do this, assuming you want to do this in your calculator, put a parenthesis, put open bracket, this open bracket, this times this, close bracket, divided by open bracket, this times this, close bracket, so that you don't make a mistake. Right? Okay, so when you do that multiplication, you will have 10,278 kilowatt hour. Is that clear?
Yeah.
So, okay, exactly. So if it's clear, let's, this is another example. I think you can look, if you understand it, then you can also understand this further example. Let me just pause it because I want us to finish this as quickly as possible. Is it the same way? The same way I've solved the past 3 examples. It's the same way that you're going to solve this example. So you have these materials. Let us go into point of use cost. Now you're going to see the importance of this energy consumption. Now, there's what we call point of use cost. Now, assuming that you want to heat a boiler with a coal, okay, and you also have the option to heat that boiler with a gas. Now, somebody will ask you, which of the fuel source would you recommend? Heating the boiler with a coal. Now, a coal can be cheaper. Mind you, the coal can be cheaper. You can source the coal cheaply. But again, you know that the efficiency of that coal is also low, right? And if you're using a gas can be a little bit expensive, but it has a higher efficiency, right? So how do you now compare these two? How do you now determine which one is more recommended? Which one would you recommend? If you're an energy consultant, which one would you recommend? A client is now asking you, I can power this gas, I can power this my boiler, I can power it with a coal, and I can also power it with a gas. Which one would you recommend? For you to be able to know what to recommend, you need to do point of use cost. You need to do some calculations to arrive at which one is more viable, which one is best to use, okay? And to do that calculation, that's what we call point of use costs, okay? So I'm just trying to create a background or lay an understand create an understanding of what point of use cost is and how it applies to us as an energy consultant. So let us proceed. So point of use cost depends on energy purchasing price and efficiency of use. I made mention of these 2 things. The coal can be cheaper, it's cheap, but the efficiency is low. The gas can be a little bit expensive, but it has a higher efficiency. So how do you know which one is better to choose? Okay, Exactly. So now, energy sources can be compared using point of use cost, converted to a common base or common unit. And this is where the importance of that energy conversion that we just did, this is where it comes in. For you to compare the gas and the coal, you must bring both of them to a common unit to compare them. Okay, you must bring all of them. In most cases, it's usually in gigajoule. You bring all of them, the output from them, from both the gas and the coal, bring out the output in gigajoule based on their efficiency. What is it going to give you in gigajoule? When you now have those values, you can now make your comparison. Which one is more preferable? Okay, so gigajoule is often used as a common basis or common unit for this comparison. So here is the formula for calculating point of use. The purchasing cost per common unit. Pay attention to this. The purchasing cost per common unit. So you must bring all of them to a common unit. Then you now determine the purchasing cost at that common unit. Then you now divide by efficiency of the energy use. You're going to solve an example, you understand this. So this is an example. A steam boiler for a facility can operate on propane, which is an LPG gas, or fuel oil, okay? Now the question, which one would you recommend? Now, using LPG gas, now this is the cost of LPG gas. It costs $1.25 per kilogram. And each kilogram contains 45,650 kilojoule of energy. Now this boiler, the boiler is 75% efficient. If you're using LPG, it has 75 efficiency, right? Alternatively, you can use fuel oil. Now, if you're using fuel oil, the fuel oil is cheaper, $1 per liter for the fuel oil. And then the energy content per liter is 35,000 kilojoule. 39. Now, the boiler is 78% efficient. Now, the question is, which fuel source provides the lowest operating cost for this client? Do we understand the question?
Yes.
This customer has two options. He can go for a boiler that uses LPG or a boiler that uses fuel oil. He's confused because he doesn't know what the cost would be for him. He brought you in as an energy consultant to advise him. How would you advise him? So we're going to solve this question. Okay. Yes. So now, select 1 gigajoule as a common unit of steam output. Now, both of the boilers, their output is steam, right? So you want, remember what I said, when you want to solve point of use cost, you have to bring both of them to the common unit. So we are choosing gigajoule as our common unit. So let us calculate the point of use cost for LPG. This is LPG. Let us calculate the point of use cost, okay? That's, we want to calculate the dollar per gigajoule. We want to know what is the dollar per gigajoule, right? Now, if you look at the question, they told us that LPG costs $1.25 per kilogram. But we want to know what is the cost per gigajoule. Okay, so and then we were also told, in fact, we are given the conversion factor here. The boiler, the LPG gas cost $1.25, and one kilogram contains 45,650 kilojoule. So we put that into our calculator here. So 1 kilojoule will give you 45,600. Sorry, 1 kilogram will give you 45,650 kilojoule. Now look at what I've done. Look at what we've done. We put kilogram on top so that we can cancel this. Remember what I say, we always alternate the unit that you want to cancel out. So we put the kilogram on top so we can cancel this kilogram, right? So, but we are going to gigajoule, not kilogram. And we know that 1 million kilojoule is equal to 1 gigajoule. So if you want to, if you want to do another, intermediate here, you can combine this into megajoule. So 1,000 kilojoule will give you 1 megajoule. Then another 1,000 megajoule will give you 1 gigajoule. But we are going straight. I don't want you to be confused. 1 million kilojoule. So if you're converting kilo to giga, you're dividing by 1,000, right? I mean, you're dividing by 1 million.
Yeah.
Are we together? If anyone is lost, please speak up so that I can explain.
Well, with you.
Okay. So you now alternate the unit here because your intention is to cancel out this kilojoule so that you're left with only gigajoule, right? So you've canceled out kilojoule, you've canceled out kilogram. You now cancel out kilojoule. So you're now left with this dollar per gigajoule. So you multiply, you now divide by your efficiency. Remember our formula for point of use. You're dividing by efficiency of use. So you now divide by 1/0.75% efficiency. Once you've done this, you now multiply $1.25 times 1 times 1 million kilo, 1 million, of course, you know, you've canceled this kilojoule, divided by 45,650 times 0.75. So when you do that, you're going to, please punch this in your calculator and be sure that we got the same thing. 1.25 times 1 times 1 million divided by 45,650 times 0.75. Please remember to put this in brackets. All these denominators, put them in brackets. Please do that and let us be sure that we got this at 6.51. You know, sometimes when I'm doing this, or if we are doing this, sometimes we could also make a mistake. But if you don't do it, you will not realize that we made a mistake. So please calculate so that let us be sure that what I have here is the correct value. If anybody has the correct, just let me know so we can proceed. No,
36.5096. Yeah, I think
exactly right. So okay, so correct. So that is the cost per gigajoule. Now let us calculate the cost per gigajoule for using oil. We do the same thing. We are told we are given the cost of the oil as $1 per liter. So we convert that liter to kilojoule. We are given the conversion factor in that question. We are told that 1 liter contains 39,000 kilojoule, right? So looks like okay. So we alternate the value because we want to cancel out this liter. We alternate the values and we have 39,000 kilojoule. We now convert this kilojoule to gigajoule. So we use 1 million. So we cancel out this kilojoule. So we are left with gigajoule. And then the efficiency is 0.78, right? So when we do this, we are going to arrive at $32.87 per gigajoule. Are we together?
no.
So now we can now compare the two of them. They are now both on the same base unit, gigajoule. So the LPG costs $36.51 per gigajoule, whereas the fuel oil is going to cost $32.87 per gigajoule. Now, which one would you recommend based on this?
The lower one.
Exactly. So the fuel oil has a lower point of use cost. Okay. So we recommend this lower one. But if you don't do this, calculation, there's no way you can know which one to recommend. That's why it's important that you do this point of use calculation.
So one question.
Okay.
So assuming we are not given the conversion factor in the case of LPG 45,650, is it on the conversion table?
Yes, you can go to the convert. Okay, let us check if it's so we want to convert
kilograms to gigajoule.
Now that is LPG gas. Let us see if it's in the table. If it's not there, then you can search the internet and get it. So let us see.
Okay, is there to megajoules?
Exactly. So it's there. So even if you're not giving, you just come to the table and find it and then use it. So let's. So this is an alternate example. Now, in this alternate example, instead of converting to kilojoule, instead of converting to gigajoule, you can decide to use your base unit to be kilowatt hour, if that is more convenient for you. But the point is that make sure that you have the same unit, the same base unit for two of them to compare. Understand? That is just the basis. So we can also decide to do, instead of converting to gigajoule, in our previous example, we can decide to convert to kilowatt hour, and then you compare both of them. So in this case, when we converted to kilowatt hour, we had 0.131 per kilowatt hour for LPG, and we have 0.118 per kilowatt hour for the fuel oil. So it's still the same thing. We find out that the fuel oil is lower. The same thing, you're going to get the same result. So this is an exercise. Can we try? Can we try this? Can we try this? Or maybe just walk us through this. Let us do it together so that we don't waste much time. So now, for a large boiler, you have the choice of the following energy sources. Now they are asking you to calculate the point of use cost per gigajoule for each. So you're converting to gigajoule, right? So you have natural gas, you have fuel oil, then you have electricity. The question now is, which one would you recommend? Okay. So let us calculate the point of use for every one of them. So for the natural gas, we are given that it's, so let us do, you can draw your line, your real cross line. Then the first thing you're going to put is $0.40. Okay. $0.40. Okay. Then underneath you put meter cube. Have you done that? Underneath you put meter cube. Just like we did here, we wrote 1.25, then underneath we have kilogram, which is what we are given in the question. So please do that for the natural gas.
Okay.
So if you draw your line, you put 0.04 rather, then underneath you put meter cube. Then we are given the conversion factor. 1 meter cube is equal to 37,000 kilojoule, right? Now you're going to write the meter cube up so that you can cancel out. Then below it, you're going to write 37,000 kilojoule. Now, mind you, we want to convert to gigajoule. Okay. Now remember that 1 million kilojoule is equal to 1 gigajoule, right? So next thing you're going to do, you're going to write 1 million kilojoule, and below it you're going to write 1 gigajoule. I want you to be doing it on your own worksheet as I'm doing as you proceed. Then the next section
over what? Over what?
Yes, 1
over
gigajoule. What? 1 gigajoule.
Okay, okay.
So next thing you're going to do, you are not going to put in the efficiency. So 1 over 0.86. 1 over 0.86. That is the efficiency of the natural gas.
Mm.
If you've done that correctly, you notice that the meter cube will cancel meter cube, right?
Yes.
Kilojoule will cancel kilojoule, right?
Yes.
So you have only gigajoule left. So multiply everything on top and then divide it by the multiplication of everything below.
What we have on top is 0.00 times 1 million, Abi?
0.40, not 0.0. 0.4
Okay.
times
0.4.
1 million.
Okay, okay.
Divided by, you open a bracket, that's 7,000 times 0.86. You close the bracket, you check.
Did you say 97,000 or 37,000?
37,000, please.
Okay.
So that's 12.5707.
So 12, what that means is $12.57 per what?
Per cubic meter.
No, we are converting to gigajoule.
Oh,
So,
gigajoule, sorry.
Yeah, so it is $12.57 per gigajoule. You want to bring them to a common unit. You are told to convert all of them to a common unit, which is gigajoule, so you can compare them. So we have calculated the point of use cost for natural gas. That's what we've done. So the point of use cost for using a natural gas is $12.57 per gigajoule. Is that clear?
Yes.
Okay, so can you try do the point of use cost for fuel oil? Just do it on your own. Let me see if we're going to get it correct.
Sorry, still on natural gas, I got 12.57. Is that correct?
Yes, that's correct. That's correct.
Okay, okay.
So do for fuel oil.
So, okay, 12.5%. What's the unit itself? Okay.
No, it's not percent. $12.57.
Okay.
Per gigajoule. If you look at it, you've cancelled that meter cube. You've cancelled that kilojoule. The only thing you have remaining is the dollar and gigajoule. That's what you have. So please pay attention to the units.
Okay. Yes. Per gigajoule. Okay. Okay.
So do for the natural fuel oil, please. Let me see if we're going to get it correct. I just need to be sure that we understand this thing.
All right. Fuel oil.
Please, if anybody has got it, let me know.
So that's 23.0405 gigajoule.
Okay,
Oh,
that's
dollars
correct.
per gigajoule, yes.
Exactly, that's correct. That's correct. Who has got it correct? Has any other person gotten it correct? I just don't want to be. I just want to be sure that we all understand this.
You need to the liter. Okay, liter is the common base. Okay.
I mean, are we there?
We are on it, please.
So for the person that got the first the answer for the 4 you can proceed and then try your hands on the electricity. See if you can also get the point of use cost per gigajoule, dollar per gigajoule. So when you're doing for the electricity, you are given in kilowatts hour. So check your conversion table. How many kilowatt hour are in gigajoule? What is the conversion factor between kilowatt hour and gigajoule? So you just go straight to gigajoule and you then divide by your efficiency to get your answer. If anybody tells me the answer for electricity, we'll just go ahead. Nobody has gotten the answer for electricity. So for the electricity, what you actually okay.
Okay. So that's $26.93.
Correct.
Gigajoules.
Awesome. Correct. Yes. So I'm glad that you understand this. Okay, it is very, very important, because one of the challenges you're going to face as an energy consultant when you go out there is people will present you, data with different units. So you need to understand how to convert those units to a base unit so you can do your comparison. If you don't convert them to a base unit, you can't do any comparison. The same thing which I taught you when you're doing your economic evaluation. You need to convert those your investments to a common. You need to use the same element to measure all of them before I can be able to say, oh, this one is more viable. So sometimes you might need to do your net present value to be able to decide if it's a viable investment or not. So for this case, if you want to determine which of the fuel source that you should recommend for your customer, you have to do your point of use analysis to determine which one is going to actually cost your customer less. So for this three now, these are the three answers. So for the natural gas, we have 12.57. If the customer is using fuel oil, it's going to cost him 23.05 per gigajoule. All of them is per gigajoule. If he's using electricity, it's going to cost him 26.93 per gigajoule. So which one would you recommend for the customer?
Natural gas.
Exactly. So you're going to recommend natural gas because
Natural gas, yes.
Yeah, exactly. So, but if you don't do this calculation, you wouldn't know. So you need to do your point of use calculation to be able to determine which one is more viable. So I will just quickly rush this. I mean, I think there is no much. This is just theory. You can read this stuff, but I'll just rush through it. So I'm going to talk about benchmarking. Benchmarking. So what is the essence of benchmarking? Now, basic measure of facility. Benchmarking itself, okay, is more like a platform through which you can compare different facilities. So you're comparing apple to apple, and you're not comparing apple to orange. It is very, very important in energy calculation. Okay. So one of the ways through which we benchmark facility. Okay. So if you have maybe NNPC towers, you want to compare NNPC tower with CBN. Okay. Which parameters are you going to compare both of them to say, okay, oh, this one is actually consuming more energy? You need a common definition to be able to compare both of them. So that is why energy benchmarking is very, very important. And one of the ways we benchmark is through the use of energy use index. Okay, energy use index is one of the ways to benchmark facilities. So if you want to compare NNPC with CBN, you can use energy use index to benchmark them. So what is energy use index? It is a basic measure of facilities' energy performance. It is a statement of a number of megajoule of energy. I know we are not very conversant with megajoule, gigajoule. Please let us not be confused. It is a higher unit of kilowatt hour. Okay, so you can convert kilowatt hour into kilojoule, megajoule, and gigajoule. So when you're dealing with a large volume of energy, in most cases they use megajoule or gigajoule. So let us not get confused. So it is a statement of a number of megajoule of energy used annually per square meter of conditioned space. So if you want to rent an office space, sometimes they will pay you 20,000 naira per square meter. So depending on the number of square meters that you want, you cannot be able to calculate your rent, right? So this the same way applies to energy. You know, how much energy are you using per square meter in megajoule? That's how you can compare this facility. So if you look at CBN, what is the square meter of the building? If you look at NNPC, what is the square meter per the building? What is the total square meter of the building? You now divide it by the energy that they consume. So you now get energy consumption per square meter. Based on that per square meter arrangement, you can ask, oh, NNPC uses more energy per square meter than CBN, or CBN uses more energy per square meter than NNPC. I want you to understand the concept of energy use index. Is that clear?
Not quite.
So maybe as along the line, it becomes more clear. So to compute the energy use index, you have to identify all the forms of energy that are used in that facility. Okay. You tabulate the total energy in megajoule used in the facility. Then you determine the total number of square meters of conditioned space. So I explained this earlier, but let me explain this again. If you want to compare the energy energy consumption between NNPC building and CBN. How can you do that? Somebody is asking you a question. NNPC uses certain amount of energy. CBN, okay, let me put a number to it. NNPC uses 1 million kilowatt hour in a year. Okay, I want you to note that 1 million kilowatt hour in a year. Okay, and then CBN uses 800,000 kilowatt hour in a year. That is CBN. Okay, and then NNPC has a floor size. Maybe I should just sorry, let me write this down so that we can see. Let me explain what. So NNPC building uses an energy consumption of 1 million kilowatt hour. Okay, and then NNPC floor area is NNPC has a floor area of maybe say just as an example, 30,000 square meters. 30,000 meters square. Okay. How do I do this? Okay. So NNPC has a floor area of 30,000 square meters. All right. Now let us look at CBN. Sorry. Okay. So let us look at CBN. CBN uses maybe 800,000 kilowatts hour, right? Now this is the energy consumption. And let us say that CBN CBN has a floor area is equals to 50,000. So let's say, sure. Sorry. Let's say it has 50,000 square meters. Okay. So if this is the detail we have, we want to compare which one uses more energy. Okay. So how do we calculate energy use index? So energy use index for NNPC is equals to, now the amount of energy that they use for the year, which is what? 1 million. We are going to divide it by their floor area. Their floor area is what? 30,000 meters square, right? So divide it and let's see what we get. What do we have? Hello, are you with me?
That should be about 30 point something. Let's see.
33.33 kilowatts hour per meter square. Right? I'm trying to copy just this meter square so that I don't, it's not, but I hope you understand. So,
Yep.
for the NNPC, energy use index is 33.33 kilowatt hour per square meter, right?
Yes.
Okay. I want to understand what I want to demonstrate here is how we calculate energy use index. Okay. So now let us calculate for CBN. So what will be CBN energy use index? So we are going to do their energy consumption, which is 800,000 divided by their floor area, which is 50,000, right?
Yeah.
Okay. So what do we have? 800,000 divided by 50,000.
16.
50, 1, 2, 3. 16. Okay, correct. So we have 16. So what that is 16 kilowatts hour per meter
Square.
yeah, per meter square. Right? So you can now see which one uses more energy based on the CBN energy use index for the CBN and energy use index for the NNPC. Which one uses higher amount of energy?
NNPC.
So you can now see that NNPC building uses a higher volume of energy than the CBN. So the essence of energy use index is to compare two different facilities with different characteristics. So you know which one is actually using more energy per square meter, right? So like I said, it's a way to benchmark different buildings. So this is how it works. If I'm producing chocolate, for example, and maybe Engineer Ephraim is also producing chocolate, we are selling to the same number of customers. If I'm spending, now this is energy use index for maybe production companies. If I'm spending 20 units of energy to produce one chocolate, as I said to my customer, and Engineer Ephraim is spending 15 units of energy to produce that same chocolate, who has an upper hand? Who can do better? Who has more competitive advantage?
The one with the lower energy use index.
Exactly. So this is how you benchmark two different people who are doing almost the same thing, or two different buildings, to know which one is doing better. Okay. So it is important we know how to benchmark, how to compare maybe facilities or even a production facilities. So this is energy use index. Okay. So there is also I've explained all of this. So but in this case, they're not using megajoule. Remember, I used kilowatt hour, but here they're using megajoule. In this example, they're using megajoule per meter square, right? So it's the same thing, right? But the point is that you understand how to derive it. So let me just go ahead. I've talked so much about energy use index, and now in US they have done a research to establish the energy use index for several sectors of the economy. Okay, so for education, this is the energy use index for the education. It's about 800 or so. Yeah, megajoule. This is megajoule per meter square per year. It's 800. So the highest for them is food service. Food service has the highest energy use index. So food service consumes more energy in US than any other sector. That's what it means. Followed by their food sales, right? Followed by their health sector. So if you're running a health business in America and you're using 2,000 megajoule per meter square per year, then something is wrong. You're using more than you should. So this is American statistics anyway. Nobody has done that for Nigeria to determine what it is. Maybe we can take it upon ourselves someday to go into research and then provide all of this data, so we can be able to advance our energy transition process. So this is further examples of energy use index. I want us to talk about energy cost index. So this is energy cost index. So in the same way we did for energy use index, in this case, instead of use, you are not using that cost. So you are dividing, instead of the amount of energy divided by the floor area, you're not dividing the cost of the energy by the floor area. That's just only the difference. Okay? I want you to get this. The difference between energy use index and energy cost index. Energy use index, you're dividing the floor area. You're dividing the quantity of energy that is used by the floor area. But in energy cost index, you're dividing the cost of the energy by the floor area. That's only the difference. So it's the same thing, but only that instead of quantity of energy used, you're using cost of the energy. That's the difference. Is that clear?
Yeah, it's clear, but I have a question.
Okay.
So why are they using the floor area because there could be varying equipment installed in the floor area that may use different amount of energy. For instance,
Exactly.
if you are
Very-
just having lighting point and the other one is using, say, electric motor, for sure, the cost of the energy will be higher with the one using machines. So why is it
Yes.
a floor area in this case?
Very good observation. So it depends on the facility that you want to compare. You need to be careful, make sure that you're comparing apple to apple. So if you're comparing a hotel industry, make sure you're comparing a hotel building with another hotel building. You're not comparing a hotel building with a factory, right? Make sure that the comparison is apple to apple. That's one. Two, there's a caveat here. It says conditioned space. So even if you're comparing hotel to hotel, the floor area that you're considering are the air-conditioned space, not maybe the atrium, maybe a veranda that's exposed to the space. So there's a caveat. It has to be the conditioned side, the area that you have a climatic control. You want to control the space for human habitation, right? So it also tells you the kind of area you have to look at, not all the floor area, but the conditioned floor area. So you're comparing, so it's just and again, I must say that this is a weak indicator. It is a weak indicator. A more stronger indicator is the one I told you about chocolate. Is a more stronger indicator. Okay. So in that case, in most cases, we refer to them as specific energy consumption, not energy use index. Professionally, when we are talking about production facility, maybe for factories, we use, instead of energy use index, we are using specific energy consumption. So how much energy do you use to produce 1 kilogram of your product? Does that make sense?
Yeah, it does. Thanks.
Okay. So I have talked about the energy cost index. We are winding down shortly. So energy cost index. So I mean that is it. I think for now, is that something else? Okay, this is benchmarking is a value. I've explained this already. The essence of energy use index, energy cost index, or even specific energy consumption is to benchmark so that I can be able to compare something against something. I've already explained this. I didn't even know there's a special slide for it, but I've explained it already. And I think the explanation I gave is the same thing as, if you read this whole theory, it's the same way I've explained it. It might even give you a better understanding. Okay. So this is benchmarking comparison in energy efficiency and water use. Like I said, benchmarking is just a way to compare something to something, but you must be careful to make sure that you're also comparing something that are similar, not apple to orange. Okay. So there are different ways to do. You can benchmark water use. You can benchmark energy consumption. You can benchmark energy use per kilogram of production. Okay. So that's what all of this is all about. So this is talking about benchmarking using natural gas, total energy, water, electric, different forms of energy. So you can easily read all of this up. And it's not saying that sometimes governments might require benchmarking. In some countries, I know in US, they take it seriously. They use energy, especially energy use index. They use it a lot in the US. Okay, so some government agencies might require that you do energy benchmarking. Okay, maybe for regulatory purposes or all of that. So I think that is it all from me today, and I think that brings our training to the end. I'm so sorry for exceeding our time. It's already 6:30 something, and we ought to have stopped at 6 o'clock, but I guess we are fine with it. Do you have any questions, comments, suggestions on how we can do better? I just need a feedback, please.
Oh, how we can do better, or what we have done so far.
So maybe
before
also,
we talk about how we can do better, please, because I think I didn't do this electricity stuff. I did the natural gas and the fuel oil. Please,
okay.
The other guy, that whether it's you who just run me through, and on electricity, where we have this 0.095 kilowatt hour, and the efficiency was 98%.
Yeah. So this electricity, right?
Yes.
So if you do, so let me walk you through it. So if you do your well track line, on the first part of it, write 0.095 on the
I've done that.
Then on the bottom, write 1 kilowatt hour.
Exactly, I've done that.
Then in the next section, write 1 kilowatt hour on top.
On top. Mm-hmm.
Yeah. Now go to your conversion table. What is 1 kilowatt hour in gigajoule?
In gigajoule is 0.0036 gigajoule.
So write it at the bottom.
Okay, very good.
Then the next one is the efficiency, which is 1 over 0.98.
0.98.
Exactly.
Okay.
So you do that, you get your answer correct.
Okay. Thank you very much. Mm-hmm.
Okay, very well. Any further question? No further question. Okay. Thank you so much. I mean, for staying up to this final moment. Go ahead.
Yeah. So mine is just a comment.
Okay.
So I'd like to say it's a very good course. I think I've benefited a lot for the 3 days training. And I don't know which other modules you have. I'm sorry that I didn't join the previous ones, but I guess I can also look through it on the YouTube. Well, if you have something more, let me know. I would like to, benefit from it. My other comment is on the time keeping. It seems I noticed that we don't start on time. I believe if we had started on time, we would have, finished on time as well. Yeah, exactly. Yeah, because now we have exceeded by almost 40 minutes. So let's try to improve on that in the next modules. So thank you so much. It was quite useful training. I really appreciate it. Thank you.
Okay. Then I think I need to stop.